Traditionally, security checks and testing are performed towards the end of the software development lifecycle. However, discovering vulnerabilities at that stage can be costly and time-consuming. This observation has led to the shift-left movement, which advocates for implementing security testing earlier in the software development process. HoundDog AI is a startup focused on software to enable shift-left security practices. Amjad Afanah and Sudipta Mukherjee are co-founders of HoundDog, and they join the show to talk about their company. Gregor Vand is a security-focused technologist and is the founder and CTO of MailPass. Previously, Gregor was a CTO across cybersecurity, cyber insurance, and general software engineering companies. He has been based in Asia Pacific for almost a decade and can be found via his profile at vand.hk.
Hi, I'm Amjad and Sudipta. Welcome to Software Engineering Daily.
Thank you for having us.
Yeah, it's great to have you both here from HoundDog AI. Love to maybe just kick off with kind of hearing about both of your backgrounds. Maybe Amjad, do you want to start off where have you kind of come from in the journey to HoundDog AI?
Yeah, appreciate it. Thank you for having us. So my journey started back in 2006 when I basically finished college. I moved to the Bay Area, started working for enterprise software companies. I first joined Oracle and then VMware. And in both capacities, I was a product manager, basically managing enterprise software product lines that had to do with application monitoring and cloud automation. And my entrepreneurial journey started when I met a very smart engineer at VMware. And this was back in 2014 when Docker was kind of rising as a kind of a disruptive technology that it was helping developers deploy applications more easily. And we figured that, hey, we're at VMware, we know how enterprise applications should be deployed. Maybe we can extend our knowledge to the world of Docker containers. And we started our first company. It was a company called DCHQ. And then a year and a half into it, it was a very competitive space, a lot of different container orchestration tools and cloud management vendors. But we were very proud of what we built, and we integrated with 15 different clouds and really simplified the containerization of enterprise kind of existing applications as opposed to kind of greenfield, microservice type of applications. And then a year and a half into that, we actually ended up getting acquired. It was a company in the hyperconverged infrastructure space that was trying to pivot into cloud management. I ended up staying with that company for a couple of years. And then my introduction into the world of cybersecurity was back in 2018 when that same co-founder and I decided to start a company that provided the first API security scanning technology. And the idea was to basically scan your open API spec or Swagger file, and we would generate a whole bunch of tests that would look into SQL injection, denial of service attacks, all that stuff. And the thing that distinguished us was around access controls, right? Because a lot of the API attacks that happen are because of privilege escalation, somebody having access to more APIs or more things than they shouldn't have. And so we would basically ask our customers to provide kind of a pen test type of experience, but they would provide credentials to the different roles they have in their application. And we would generate tests that will basically mimic what kinds of access they have to the various API endpoints using these different roles. And then they would see, admin has more access than it should have. And then they would kind of remediate accordingly. And then I ended up leaving that company for different reasons, mainly because I was kind of recruited by the self-driving car company called Cruise. And that was supposed to be the next OpenAI. Unfortunately, didn't pan out accordingly. But they basically wanted somebody to manage the developer experience and infrastructure services product management team, and stuck around for 2.5 years and then decided that, hey, I want to get back into cybersecurity. So back in 2022, I joined a company called Cyro, and it was a company in the data security space. So I joined as the VP of product. And really, it was that my time at Cyro that really inspired me to start HoundDog, and I can kind of get into the details later about some of the kind of the learnings I learned from the security and privacy teams while at Cyro that helped kind of formulate a lot of the core kind of thesis that we started for HoundDog, right? So that was my high level journey. Yeah, and I'll turn it over to Sudipta to talk about his journey. Yeah.
So yeah, my journey started like around, I think, 20 years back. And I have been programming different kinds of software since then. But do a reverse chronological tour of my journey. So I think recent years, about last decade or so, I have been involved in a lot of compilers and tooling around and programming language development work. So I worked as a compiler backend engineer for developing compilers for language that are defunct now, but are still there. And I had written a compiler for a language that's called App Builder, but it's not the Google App Builder. It's a COBOL DSL, but essentially we written the compiler in C# for emitting MSIL. But that was my initial touch on the compilers, and then I had a knack on metaprogramming and identifying things that are writing code that will be identifying things that are a lot of glitches in the code bases. So I wrote a book called Source Code Analytics using Microsoft's Roslyn and JavaScript visualization engine. And that was in 2016. And so that was received well. And since then, I had been experimenting with different kinds of metaprogramming approaches to identify not only just the bad programming practices or identifying things in the code, but also kind of clustering developers and identifying using machine learning and programming languages techniques. I always wanted to work in the a cross section of ML and PL. And so when we got the opportunity to work with Amjad, that was a very happy accident, and it's a win-win situation. So I readily joined that. So this is the brief history with programming language tools. Before that, I had worked with enterprise software for developing lots of other things. I would not go there. It's a long history. Yeah, so.
Yeah, wow. So two, I would say, quite varied backgrounds. I think Amjad, your background tallies a bit closer to mine, maybe, especially where you talk about coming to cybersecurity at that sort of point. And I think that's super interesting because I think a lot of people assume you either start in cybersecurity and that's your life, or you're not. And actually, I think some of the best tooling and platforms in cybersecurity now come out of people that have transitioned to the cybersecurity side from kind of watching it from the sidelines a bit and then going, you know what, actually, I think we can do something better here. So yeah, super interesting from both of you. So the platform, it's called HoundDog. I'd love to just also understand the name. If you Google HoundDog, a couple of platforms come up. So I just want to super clarify, it's HoundDog AI that we're talking about today. Yeah, so I guess where's the name from? And then also at a high level, what is HoundDog AI? What problems did you want to solve through this? And why did you kind of think we want to solve this problem or these problems through a venture?
Right. Yeah. So starting with the name, it's actually really hard to come up with a unique name. And there seems to be a lot of dogs in the cybersecurity space, but it's understandable because a dog is a kind of a loyal companion that hunts for things and helps you discover things and helps you kind of identify things. So I figured HoundDog is the perfect kind of name for the animal that's going to help us hunt for these data security vulnerabilities that we're looking for. And yeah, basically when we started last year, there was an insurance company that had HoundDog.com, and I was like, okay, that's great. And then just recently discovered this, there's HoundDogAI.com, and it's some financial modeling tool, and it just kind of appeared out of nowhere. And yeah, but
it happens. It happens to the best of us.
Exactly. Yeah, and in terms of what we're trying to solve, right? So I was kind of talking about my days at Cyril, and that's really what inspired me to kind of start this company. And so Cyril is a data security company, and like many others in that space, it basically helps you discover and classify your structured data in production environment, right? And then apply access controls accordingly. And while I was at Cyril, basically the feedback I was getting from a lot of security and privacy teams was that the product and the kind of that approach makes sense. But what is missing is a more kind of proactive approach, because everything that's out there is very reactive, right? It's kind of assuming that you already have something in production, you have to discover it, classify it, and then apply the access controls. But what if you really wanted to prevent like personally identifiable information from leaking into logs or files or third-party systems from the start, right? Before the ripple effect happens, and before, when you leak something into logs, it's not just the logs. There's like a whole bunch of systems that could potentially ingest logs, right? Like, there's Sentry, there's Datadog for observability. There's like the SIEM tools like Sumo Logic and Splunk. There's backup systems. It's like many, many different systems that may end up kind of having like this sensitive data exposed in, right? And so that was like one of the first insights. And then that was from a security standpoint. From a privacy standpoint, it's actually a really big mess, right? For GDPR compliance, there was like a survey that was done by one of the data privacy platforms. And basically they asked a question, which is, what's the level of effort that's needed for you to discover all the systems that are handling user data and then come up with like a unified data map, right? The 58% or the overwhelming majority, right, said that it takes multiple teams and an external vendor and at least 1 year in order to complete that task. So 1 year, they spend the whole year between like manual surveys and like, checking with different teams and understanding what data flows they're kind of processing and all that stuff, just to kind of create that unified data map that is needed for documenting processing activities for compliance. And then in addition to that, there was another question asking, how often do you add systems that like process user data? And majority of the respondents said weekly, right? So it's not like it's a constant thing. It's something that continues to change, and it takes a long time because of the manual approach that they're taking. So we figured that, hey, what if we build a code scanner that really understands the data flows that are handling sensitive data? And it could be used for two use cases. One is like flagging and preventing these PII leaks from the start, and helping you document processing activities that keeps up with the changes in the code base, so you don't have to go through all that manual process, basically. Yeah.
Yes. Okay. So PII, sort of the headline there in terms of, as you say, like two kind of use cases, effectively being able to protect against leaks, and then also being able to keep on top of where is the PII and what are those data flows, and especially for compliance, in the run up to a SOC 2 or something along those lines. And then just sort of briefly, what is HoundDog AI? What was it not solving? Just to also kind of clear that one up.
Yeah. So one of the questions that keeps coming up when we talk about like detecting sensitive data flows is like the thing that they are kind of accustomed to knowing, which is what's already available in the SaaS scanners or the code scanners today. And that's the exposed secrets detection, right? And so that's like what we're not doing, because it's a different kind of problem, right? So exposed secrets are looking for actual exposed API tokens or passwords that you've embedded in the code. Whereas what we're doing is understanding the code logic that's handling sensitive data. So you may be creating a function or a method that's about to handle social security. And we will intelligently know, based on the naming of the different things and the various kind of analysis techniques that, Sudipta is happily to drill down into, we will know that, okay, this function with a certain degree of confidence is handling social security. And then we kind of track it across the code base to see, okay, what are you doing with it? Are you kind of exposing it in logs? Are you saving it in plain text in a file? Are you sending it to Sentry or Datadog? So that's kind of like what we're doing. And we're not doing the secrets detection because, to be honest, it's become like a commoditized feature that every SaaS scanner is now offering.
Yeah, I think that's a really good thing to point out. They could sound like the same problem to solve, but they really are not. And as you say, secret detection has definitely been around for a bit longer. And, there's some really great companies out there that specialize in that, like Trufflehog comes to mind. And that's another animal in there, not a dog, but a hog.
Right.
Yeah. So let's maybe just get into the weeds a bit of how does the sort of the platform work, in detail. I think the sort of the high level here is it's both static analysis and AI. And I think I'd love to sort of understand, where do you see the static analysis being the powerful piece? And then, it sounds obvious, but I'm going to ask why also go to AI as well? And, how do those two approaches work together? What are the limitations of each? I think in this context, there's just a lot to unpack there.
Okay. So HoundDog AI, the platform, if you will, it has a lot of moving parts, but largely there are like two big moving parts. One is the scanner, and obviously the other one, as you mentioned, is the AI component. And the scanner, when we say refer to the scanner, we refer to the static analysis component. And when we refer to AI, we refer to the OpenAI integrations. So what the scanner does is typical of a static analysis. It gets the source code and parses it and generates a syntax tree, and kinds of goes back and forth in that syntax tree to identify the tokens and also identify where exactly those tokens are used inside a program. When you say a function call, that's called invocation in terms of static analysis. And where exactly these tokens are utilized in a function call. And then, so based on that, it determines whether something is some PII data is being leaked to some other logs or not. And let's take an example just to identify it much cleaner. Let's say I have a function call that says like some logger.log. And inside that, I message something like, this is the bank account. And then I pass a variable called bank account number. So what the scanner sees is that this is a function call. Yeah, so this is like a logger.log is a function call. And then it has the argument, the function argument, like literal string that something is there. And then also the bank account number as a variable. So it knows that the bank account number is something that is obviously a PII, like PIFI in this case, like personally identifiable financial information. And then it flags that invocation as a vulnerable call because we know that logging sensitive data is a vulnerability. This is an obvious example, but our scanner is smart enough to identify like non-obvious examples. So let's say you have a variable called some string. Let's say you are doing some programming and you say string bank account equals to somewhere you got the get bank account number. And down the line, you have somewhere said like string X is equal to bank account. So now X also has the details about the bank account. And then you are saying somewhere, you say like logger.log something and X instead of bank account, you just say X. So our scanner also detects X using some taint analysis. Like what it's called taint analysis because in terms of static analysis, the bank account is called a tainted variable because it has a data which is not supposed to be there, and that's why it is called tainted. And whenever it is assigned to some other variable, that also becomes tainted. So it's, if you will, it's like more like a ladder. So it's like joining the pegs together. So X also becomes tainted, and the scanner knows that and identifies that, and it keeps track of all such. This is a trivial example, but it happens across the different, like it can be happening around the function calls and all that. So how the scanner knows that the bank account is actually a vulnerable, like a sensitive data, because we maintain like a battle-tested list of regular expressions to identify variable names, function names, token names, class names, or whatever, to know that what particular type of sensitive data is that. So for bank account number, we have a regular expression. Similarly, for let's say blood pressure, we have a regular expression, and so on and so forth. So we have rigorously tested this across scanning multiple repositories, and we now know that they are, if not 100%, let's say around 99% correct results all the time. And since they are correct, so since the basics of these are correct, so all the tainted variable detection also are obviously correct. So if we are sure that, let's say it's not just bank account number, it says something like customer bank account details. The variable name is customer bank account details. So we also know that this is a variable of interest. Then if somewhere down the line, the developer assigns that customer bank account details to some other variable, then we also know that is tainted. So this is where the capacity of static analysis using taint analysis technique that I just described. And we do something like interprocedural analysis. Like we have a function call. Let's say I have a type, and that type exposes some methods. Those are public methods. And that type, let's say I have a class called student, and that student has a function called like return gender, for example, like get gender. And instead of like, I just say like, let's say sentry dot something, capture something, and then I just say like some object of that student class and dot get gender. So I know that gender is get gender method of student class actually exposes that gender and it is going to sentry. So the scanner is very smart that way because it knows like exactly how and where different kinds of things happen. Where we needed the AI capability now is that because regex can do only this much, because we can write a regex for things that we know that we are looking for, right? For example, so if I know that I have to look for blood sugar levels in like variable declaration that associates blood sugar level, I can write a regular expression to represent the variable names that would be possibly used to define blood sugar levels. But I cannot write a regular expression for things that are unknown to me, but are possibly PII or PIFI or PHI. So for that reason, like in the wild, there could be much more sensitive data that we do not know about right now. And what we take the help of OpenAI is that we don't send the code. What we do is like we send the tokens and kind of we simplified the problem for AI to solve. It's like a binary classification, classic binary classification machine learning problem is we take basically give OpenAI some tokens and I ask it to identify that, can you tell us like if it represents sensitive data, and if it does, which category do you think it belongs to and what is your confidence about that? And then it gives us that result back. And now what we do that we take that data back to the scanner and kind of helps the scanner, because the AI does not do this traversing of trees and such things. So it just gives us like a binary answer, like this is sensitive, that is not. And so instead of like in our example, we had like X equal to bank account number, it can be like X equal to some other things that we do not know, but it probably is a bank account number. So we would know that that is a bank account number, and all the other things that I discussed about this will keep on working. So that's where the happy marriage happens between AI and static analysis.
Yeah, that's awesome detail. And I think you really sort of explained it well, how, AI is coming in here much more it's about context. Because as you say, regular expressions can be used where you're very sure of a format, and that format, really follows a pattern. And that's a much more robust way of looking at things.
Yeah, and I forgot to mention a couple of interesting points. One is that regex is a nightmare to maintain, obviously, and nobody knows how to write them well. That's one thing. And the second thing is, that is an advantage of using AI, is that we can capture like foreign language details. So some code bases that we scan had like foreign language variable names in them. So normally we see that English is used for coding, but we have seen that some code bases had some foreign language, like maybe, I don't know, it can be having a gender in some other language. And I have seen like phone numbers called in French, something. So we can identify those using AI, because obviously AI knows all the languages on the planet. And so,
yeah, I think that's great context. Yeah, a couple of anecdotes on this side, I guess. As you say, regex is very hard to maintain. It can also kind of lead to some strangely like catastrophic outcomes if they're not written properly. I remember a long time ago, a Rails app, and the app kept crashing, and it was crashing literally based on a regex. And I remember this clear as day because it was the first time Stack Overflow had saved my life. And someone who is an absolute regex, that was just all they did all day. And they said, I can look at that and say, what's happening here is called catastrophic backtracking. And I was like, oh my goodness, what the hell is that? And yeah, in sort of a project I'm working on, for example, we're looking for one-time codes to help the user. But, a one-time code looks exactly like a zip code. So where, you can't effectively regex that terribly effectively. So it's the context where this number sits that starts to bring out. So I think that it's just another sort of example of how exactly what you've just been saying, Sudipta. So, there's a sort of a bit here where if you go on HoundDog AI website, you talk a lot about CWEs. So maybe could you just sort of give just a bit of context? What is a CWE, and HoundDog, is really staying on top of the latest of these. So maybe just speak a bit to that.
I'll take a crack at this, and then Sudipta, if you want to add anything, let me know. Yeah, but CWEs, it's a common weakness enumeration maintained by the MITRE. They're basically a class of vulnerabilities across every category they can think of, right? And OWASP is another set of kind of security categories. And they also kind of, in their documentation, they reference these CWEs as well. And so there's a bunch of them that reference sensitive data exposure. So we are focusing on the ones where sensitive data is stored in plain text in places where it shouldn't be, like logs, files, cookies, JWT tokens, local storage. And then there's like a one CWE where it basically doesn't specifically mention third-party systems, and it's just basically a CWE in relation to sensitive data exposed through sent data, right? And it's like a big Uber category that's like a catch-all for anything that's being sent outside of the application in places where it shouldn't be. And for us, we interpret that as the third-party applications that shouldn't really have like highly sensitive data that shouldn't be stored there, right? And in terms of like keeping up, we basically, just stay up to date with every version update of OWASP or the CWEs. And that's how we kind of stay up to date there, yeah.
Yeah, that's good context. I think a lot of developers may have heard of CVEs, but this is, why it's quite different. Actually, it's sort of a guidance on what types of data, etc., constitute a problem effectively, and keeping on top of those. So let's maybe just look at the developer experience here. A lot of our listeners are developers. So, if they were to start wanting to kind of integrate HoundDog into their flows, like what does that kind of look like? I mean, you mentioned shifting left a lot here, which makes a lot of sense. I think understandably, listeners might be a little bit fatigued by hearing shift left, especially in the context of security. So I think it's great to kind of maybe contextualize that. Like, how is this shifting security left? How does it look in a developer's workflow? How is that easy for them to integrate? Yeah.
Again, Sudipta, feel free to chime in. But basically, the most common workflow right now is through the continuous integration workflow. So the scanner is available as a Docker container. You can run it as a CLI. So you can do kind of what we call like a point-in-time analysis, which is get two types of output. One is what we call like a sensitive data map that maps out like all the sensitive data flows in your code base. And we also have Sudipta built these amazing visualizations where you can actually track the sensitive data flows through all the files and the data sinks where it actually ends up. So that's like one type of analysis. And then the other is obviously the vulnerabilities, and they're managed by a set of vulnerability rules. And so an example of a rule is sensitive data exposed in logs. So that's one rule. And we have a whole bunch of them, like I said, like that checks if the data is going to logs, files, third-party systems, and so forth. And so obviously we want to have this be a continuous detection process. And so right now our customers are using it as part of the CI workflow. So some customers, actually before we launched our cloud platform, most of our customers had a CI workflow output the results directly in the security dashboards that they were using, right? So GitHub has an advanced security dashboard. GitLab has something called the vulnerability report. And so they didn't even have to log into our own cloud platform to do anything. It's just a scanner that runs in their CI workflow and like just magically pushes these things into a security dashboard that they're kind of consolidates all the issues from all the other kind of code scanning issues that they see. In the future, we would love to, shift it even more left and make it part of the IDE. But I think right now it's kind of a good middle ground where it's not bothering developers that much, because we also feel like in the IDE, they may not really have things kind of like figured out yet. They're maybe like just testing things, and we don't want to like start flagging like sensitive data issues there. But if you're merging to like a main branch, that's definitely like an issue, and we want to flag it and make sure like it doesn't go all the way to production, because that's what we're trying to stop is the PII leaks. from going into production, because that's where it's like a really big nightmare to fix once it's already in production.
You sort of hit the nail on the head there. Shifting left in this context, it is a balancing act because, if you're in the IDE, then, well, how many other tools to look at other things are also there? And then suddenly the developer experience is horrible because I'm just writing code and being told every 5 seconds that something's wrong. And that's not fun. So I think that's a great place to have it right now in the CI. And then you can sort of decide where to put that information as well. Because as you called out, it's not just the developer that wants to know about that. There's always going to be other people in the org that want to know about it. And that's a great sort of place to then message it out from. And, developers, companies, they're going to have to be able to actually customize this to some degree as well. I mean, you have, libraries that sort of understand what PII looks like in different contexts. But, this must be huge, geographically, industry by industry. So, how, maybe could you give some context, like how broad is that right now in the libraries that are there? And then like, what's the process for, say, a developer being able to actually then customize kind of sensitive data types that is very specific to their case?
I'll just say basically to what Sudipta was saying is that we actually initially had more data definitions. So we had like around 200, and we actually intentionally narrowed it down to just like 60 on purpose to make sure that whatever regex definitions that we have are going to yield to real true positives. And to Sudipta's point, it's like upwards of 99% like accuracy, because like we're not going to have too many combinations of what like you could call social security. We're just going to narrow it down to like the bare minimum that we are 100% sure is something that's going to, a developer will call a function for social security handling, right? Our vision is that this AI workflow is going to basically give an opportunity to not have to maintain additional regexes, right? Because ultimately our buyer is actually not the developers. Our buyer is the security team, right? And putting the onus on the security team to already know what kind of functions, method, variables the developers are writing, that's kind of like defeating the whole purpose, right? Like if they already know what functions, methods are handling sensitive data, then they don't need us, right? So that's where we're hoping that this AI thing is going to like alleviate the pain of having to maintain regex expressions. But there are use cases and edge cases, right? So for example, like we've talked to financial institutions where they intentionally, obscure the names of the variables and the functions, right? So for example, they like, Sudipta kept talking about the bank account ID or whatever. They may actually like call that variable XYZ intentionally to kind of like, increase the level of security that they have within their practices, right? So 100%. In those cases, we do give the opportunity for them to kind of define their own regexes and say like XYZ is actually translated to a bank account ID. And then we can like actively look for what they're kind of defined in our system. But we're hoping that with AI, the majority of the use cases, like the security teams don't have to lift a finger. Like it's just AI magically discovering these things for them, and they don't have to maintain regexes themselves.
Yeah, that's a super interesting point there on variable obfuscation. It's basically, it's a smart thing to do, but then in this context, suddenly there's a sort of double-edged problem, if you want to call it that. So that's great to call that out. And if we look at you talk about like the security team and like security and obviously the buyer, I've certainly experienced where a lot of these products that sort of are trying to address a problem, basically in security, they get bought often basically for compliance, and compliance tends to mean that something has to be kind of produced to say, we've produced this thing, so now we can tick the box that says we're in compliance. The shift left bit is the fact that we can catch those things earlier to mean that we get the tick at the end of the day. So how is HoundDog kind of helping to that end, in terms of compliance artifacts like, records of processing activities, for example, like that, for GDPR? Is that sort of one of the key kind of outputs per se of the platform?
Yeah, 100%. Yeah. So like the two use cases that I was describing, I would say the security one where we stop PII leaks from the source, right? Or at the source. I would say that use case is actually not driven by compliance. That use case is really driven by security teams trying to like avoid the nightmare, right? Like usually the ones who kind of, like a light bulb moment happens when you're talking to them are actually security teams who've actually experienced PII leaks already. And they know the amount of suffering they had to go through because, we kind of estimated that it takes at least 80 hours between having to do code updates to actually, like, let's say something leaked into a log. You have to review the access logs to see who actually accessed the logs, who actually saw this PII data. And then depending on what kind of PII was leaked, they may need to do risk assessments, and they may need to kind of notify customers if like actual customer PII was leaked and got compromised, right? So it's like a huge nightmare. So that one I would say is actually not driven by compliance, because security audits, they don't have clear-cut criteria, right? It's kind of vague. We're going through SOC 2 audit right now, and I'll be honest, it's like it's not very clear-cut as to like what you must and must not have. It's very lenient, let's say, right? On the privacy side, GDPR is different. GDPR is literally like, if you want to summarize GDPR in like one sentence, it's all about like, what data are you collecting? Who are you sharing it with? And if a user wants to kind of delete it or like get access to that data, can you give it to them, right? So it's all about data. It's like you really need to know what kind of data this application is processing. And privacy teams are even further removed from developers than security, right? Like with security, at least you have like an AppSec team. They're kind of like involved a little bit in the kind of reviews and all that stuff. But privacy is even farther removed, and they get like involved every once in a while when there's like a huge feature and they do like a design review, but they're not really embedded into the development process. And they're often like surprised by things, and they're often like, oh man, like we need to update these data maps. We need to do this. And so this is kind of giving them an opportunity to kind of rely on a source of truth that's continuously changing, because code is continuously changing, but they can have the peace of mind to know that, oh, okay, even if it's changing, I'll know what kind of data flows are being updated and changed, and I can easily update my data maps accordingly.
Yeah. And I mean, I guess talking about GDPR, I need to remind myself even, GDPR was a kind of European directive, and, it's kind of worked its way into some areas of, I think, the US through, I think, for example, California has a sort of pretty close version of it. But I guess is part of what you're able to provide, if we to look at data residency tracking, is that sort of one of the big pieces here where, you've got companies with different arms of the business and they need to be able to track like, okay, it's not a compliance problem if this PII leaks in this region, even though it's bad, it's just that it's not going to, cross any laws effectively. But actually, if it was to leak via this other country that does GDPR, that's a problem. Is that sort of something that HoundDog helps with as well?
Not exactly. I'll be completely honest, because our source of truth is the code base, right? And so it's very hard to know where the data will actually end up. And so if from the code base, right, like you may have data flows that will basically store in some storage, right, in a database. And what you end up doing in production in terms of like replicating the database or having to kind of basically like replication happening in different regions and all that stuff, we can't see that, right? Because we're just looking at the source code. We can't see what kind of replication technology you're using in production. But we are solving is this like even harder problem, which is this, hey, what data flows do we even collect to begin with? And what level of confidence do we have around the data flows and the data map that we already have, right? Because code is changing. And so like our prime customers have to have the intersection of two things. One is we're handling sensitive data, and B, that we have an application that's continuously changing. In this day and age, most of the companies are in that bucket because every company is becoming a technology company. Every company is building applications, and no application stays constant. You have to update it, right? You have to make changes. You have to introduce features. You have to stay ahead of the innovation. But with these changes, you're introducing risk, and that risk needs to kind of be reflected somehow in the data map that they kind of have to kind of process for GDPR.
Yeah, that makes a lot of sense. I would actually, Sudipta, come back to you just in terms of developer experience. Something I actually didn't touch on earlier was the platform supports a lot of programming languages, and that's actually something, you were giving examples, quite sort of deliberately generic examples of function X, Y. But at the same time, every language is very different in terms of how that looks. So yeah, could you maybe which languages would you say you kind of have full support on today? And what were the challenges, or has that been a challenge to kind of keep up across different languages as well?
Yeah, thanks for asking. Yeah, so we now have support for some of the major commercial languages. Like we have started with Java, then we had support for C# in terms of programming languages, but we also support SQL, and we also have OpenAPI, and also we have the, I think, GraphQL queries. So we also scan that. And we also scan the embedded SQL statements. So let's say you are writing a Java class, and you have some embedded SQL query as a string literal. When you say literal, it means just a constant string. So you can have a string, customer insert command, and then you write the command to insert the customers. And then that query that is inside that string is pure SQL. And it also will have the sensitive data, like the names of the customer. So we know now we can track that exactly. That is also something that is scanning embedded SQL. So coming back to your point, we are working on Python and Kotlin. So that will be out pretty soon. I don't want to point fingers to a date, but yeah, it should be out pretty soon. And semantically, for what we do, for all the languages that we support, so a function call is a function call across multiple languages. And it remains thankfully, the semantics of function call or invocation is same across all the programming languages. So if you call a function in JavaScript, that's exactly the same in terms of semantics when you call it in C# or Java. There is no difference. So static analysis is a huge area, but exactly what we are using, the part of static analysis that we are using for our scanning capability does not depend on the language semantics that changes. Yeah, obviously some of the language semantics changes across languages, as you mentioned, but the variable declaration or array declarations are not same, and they have some changes, but we are not really bothered by that. Or in other words, our scanner can detect things that are not necessarily required for that.
Sudipta mentioned Java, C#. We also support JavaScript and TypeScript.
Yeah, that's something I'm excited about. I'm mainly TypeScript.
Yeah, we also support TypeScript and JavaScript. That was and as I mentioned, so whatever we are doing, for what we are doing, it is same. The way to deal with the sensitive data, it may look different, but it is actually the same, because invocations are exactly the same everywhere. And also for understanding how the different classes and types, we obviously have different types of, the scanner deploys different parsers to identify. And we also use something like a tree seater, so that we have gives us a way to parse the things easily. So the data model of the scanner remains almost similar, so it does not change. Does that make sense to you?
Yeah, no, that makes a lot of sense. And I think it was mentioned that, there's a, really nice kind of, I think it was almost like dashboard, even though we talked about the CI side, but there's a dashboard to identify, data flows, etc. I'm curious because I think this is where security platforms, they've almost got two roles. One is literally saying, hey, this thing today is a problem. The other side of it is, if they can, also actually being able to educate kind of through the platform and being able to say, this is a problem, but by the way, here's why this is a problem, and here's how you might want to approach this differently in the future. It might not be there today, but I'm curious, is that something you thought about in terms of what gets presented back to the user, and then I guess in this case, the developer user?
Yeah, so I would just say basically that what we have today is we highlight these vulnerabilities, right? But as part of the onboarding of customers, we also kind of walk through the best practices. And to be honest, when it comes to sensitive data, the best practices are kind of almost already known, right? You either omit the data, if you don't need it, you don't need to send it to Sentry or Datadog, right? Like you don't need the personal identifiable information to do your debugging or to do that stuff, because in most of the cases, developers are kind of doing things to kind of simplify and like enhance the debugging experience. And sometimes they overshare, right? And so it's kind of like just educating them on like what's enough to kind of, we don't want to like hinder your debugging experience. We want you to kind of get all the info you need to debug, but you don't need like extra information that is gonna put the whole company at risk, right? So it's, you know, like you either omit it, you mask it, encrypt it, and basically that's what it boils down to, right? In all of our remediation strategies, we kind of present these things, and we've never had pushback from developers saying like, oh no, that doesn't make sense. It's usually like, oh no, like I didn't know we're kind of exposing an API token in logs, right? Like it's usually like that surprise. But yeah, I think it's going to take some time for kind of developers to really embed a lot of this kind of best practices in their development experience. Yeah.
I will add to that. Actually, the CWE site also has some recommendations about how to deal with a specific violation. And in our presentation in the dashboard, as well as we also show that recommendation. We pull that information from CWE, and we also have, as Amjad was mentioning, that we have these vulnerability rules. So we have taken those recommendations from CWE and put them in our vulnerability rules. So they surface whenever they see a violation, they have a do and do not. And so each rule has a do and do not, and they can see exactly how. And obviously that can be extended to have some code samples in the future to show them exactly what is meant. That will be even more explanatory.
Yeah, I think that's really powerful. Yeah, bringing through those definitions and explanations. And, that's a really fantastic resource that's there through CWEs. And so to bring that right in front of the developer or whoever is looking at it, I think that's super powerful. I worked on a different problem, but it's the same idea, attack surface management, and sort of bringing through CVEs and actually having to help the user understand. CVEs can sound bad, this is high priority, but actually we try to contextualize that for that given customer or company was an interesting challenge to help educate them, because otherwise everything can look urgent or everything can look completely benign. So I imagine you kind of have some of the same things there as well.
Absolutely. Yeah, exactly. And basically we give the knobs for the security or engineering team to basically mute certain types of issues, ignore certain types of issues, change ultimately what defines the severity of an issue is the sensitivity of the data for us. So they can also change the sensitivity of they'll say, hey, social security is not, I'm just giving an example, but social security is not highly sensitive for us. And they can make those changes to kind of really tune it for their use case, basically. Yeah.
Yeah, that's super powerful and helpful. So we're kind of coming to the end of the episode, but we're recording here sort of towards the end of May, and I believe it's just been announced that you've secured seed funding. And yeah, that's super exciting. I'd love to just hear just a little bit about kind of what's that going to kind of enable for HoundDog, and where do you see the next sort of 6 to 18 months going?
Yeah, thank you. Yeah, we were basically operating in stealth for the last year or so, and we finally emerged from stealth and announced our funding today. And yeah, basically with that money, we already have a few customers, but we want to basically double down on our go-to-market. We're going to be participating in events that we wouldn't have been able to do otherwise when we were in stealth, but we're kind of sponsoring Black Hat. We're attending the OWASP AppSec conference, and we're going to be out there. And then on the product side, of course, Sudipta already alluded to automated AI fixes, right? Which is kind of most SaaS scanners are going in that direction. And it makes sense that these fixes shouldn't be something that developers have to think about. It could be in the form of a pull request that just has the fix and they just kind of approve. And I think we're kind of moving in that direction, in addition to supporting more languages and basically continue to support our customers that way. Yeah.
Awesome. And I mean, does sort of additional hiring come into this as well? Are you you might not have had a chance to think about it so far, but yeah, I mean, we've got a lot of developer listeners out there. Is that something you're thinking about?
Actually, On the development side, we're good. I'll be honest, but we may be hiring on the sales side, like a kind of a sales development representative next year. So I'm sorry to the developers now, but it is just a seed round. Hopefully next year when we raise our Series A, we'll be actively hiring. Yeah.
Yeah, no, fantastic. So yeah, don't bombard Amjad with your LinkedIn's right now, but keep an eye on the company. I think, as a developer, the best thing is to check out the platform, So I believe you're in GA now. Is that that sort of part of the announcement? So where's the best place for developers just to kind of head to and get up and running?
Yeah, if you go to HoundDog AI, we have a free version of the scanner that basically gives you that beautiful sensitive data map. And you can even use your own OpenAI key to kind of get the power of AI to discover everything in your code base. And that's completely free. So all you have to do is just fill out a form. I know developers hate filling out forms, but from a CEO perspective, I just need to know who's trying out our product. You can use your personal email address and basically get access to this Docker container. We have extensive documentation publicly available. It's on our website. Please feel free to try our free scanner. Yeah.
Awesome. Well, it has been fantastic to have both of you here today. I think you've given so much detail, both on, the technical side from yourself, Sudipta, and Amjad. You've given a ton of insights, I think, which helps developers and non-developers sort of understand this space and just sort of pull back the curtain a little bit to understand how this all kind of comes together. So really appreciate that. And yeah, I mean, obviously, good luck with the funding now in place, and I hope we get to catch up again in the future.
It was an awesome conversation. Yeah, thank you so much, Greg.
Thank you for having us.